Welcome again to LR Academy of Competitive Exams. This time to the post on Electrochemistry creative problem of Cbse second year unit number 2. How many amperes would be needed to produce 60 gram of magnesium during the electrolysis of molten magnesium chloride in 2 hours? I repeat the question. How many amperes would be needed to produce 60 gram of magnesium during the electrolysis of molten magnesium chloride in 2 hours? The given data is we need to produce 60 gram of magnesium by electrolysis. The given time is 2 hours. The reaction is Mg2 plus gains 2 electrons to give Mg in elemental form, which means 24.3 gram of magnesium is deposited by 2 Faraday. How come 2 Faraday? The 2 Faraday corresponds to 2 moles of electrons. Hence, 60 gram of magnesium is deposited by 2 into 96,500 into 60 divided by 24.3. 24.3 refers to the atomic mass of magnesium, which is equal to the overall calculation comes to 4,76,543.2 coulombs of charge. Hence, from the expression of charge and current by using Faraday's laws of electrolysis, Q equal to IT. We are rearranging the equation, that is I equal to Q by T. Hence, 4,76,543.2 divided by 2 into 60 into 60. How come 60 into 60 is? We are converting the 2 hours into seconds. We get 66.2 amperes. The clue for this is 1 Faraday equal to 96,500 coulombs. We are getting 2 Faraday due to 2 electrons. 24.3 refers to atomic mass of magnesium. The available is 60 gram of magnesium. The time is 2 hours. By substituting into Faraday's formula, we are getting this. Now, question number 2. It is a repeatedly appearing 1 mark question in both the Cbse and in state board curriculum. More importantly, in Cbse as a 1 mark either in 2 mark section or 3 mark section or in 5 mark. X. Explain why nickel spatula cannot be used to stir copper sulfate solution. Nickel spatula cannot be used to stir copper sulfate solution because the E naught of Ni2 plus divided by Ni. Always write the oxidized species on the top. Ni2 plus divided by Ni equal to minus 0.25 volt, minus 0.25 volt. Whereas E naught for copper is plus 0.34, that is in positive. Hence, nickel will reduce copper when stored in copper sulfate solution. Hence, we cannot use nickel spatula or nickel utensils to store copper sulfate solution. Question number 3. Calculate the degree of dissociation alpha of 0.05 molar acetic acid solution at 298 Kelvin. Given that lambda m for acetic acid is 11.7 Siemens centimeter square mole inverse. Lambda naught m for acetate ion is 40.9 Siemens centimeter square mole inverse. Lambda naught m for H plus is 349.1 Siemens centimeter square mole inverse. By using Kohlrausch law, lambda naught m, that is molar conductivity at infinite dilution, is the sum of the contribution of the cation and the anion. Here, the electrolyte is acetic acid, that is a weak electrolyte. It dissociates into acetate ion and H plus ion. Hence, molar conductivity at infinite dilution of acetic acid equal to molar conductivity at infinite dilution of the cation and the anion sum up, that is 40.9 plus 349.1, which comes to a total of 390 Siemens centimeter square mole inverse. Lambda m, molar conductivity for acetic acid is 11.7 Siemens centimeter square mole inverse. By the formula, degree of dissociation alpha equal to lambda m divided by lambda naught m, which is equal to 11.7 divided by 390, that is we are rounding off 390. We are getting a degree of dissociation as 3 into 10 to the power minus 2, that is alpha, degree of dissociation. Here we are incorporating two formulas, that is Kohlrausch law, limiting molar conductivity, and degree of dissociation alpha by using the formula lambda m divided by lambda naught m. The next problem is calculate the time to deposit 1.27 gram of copper at cathode when a current of 2 amperes was passed through the solution of copper sulfate. Molar mass of copper is 63.5 gram mole inverse. 1 Faraday, as we all know, it is 96,500 coulombs. Copper gains 2 electrons to become copper. So 63.5 gram will require 2 Faradays, that is 2 into 96,500 coulomb of electricity, because the number of moles of electron involved is 2. Hence, 1.27 gram will require 2 into 96,500 into 1.27, that is I have simplified to 1.2, divided by 63.5, which is equal to 3,860 coulombs. This is for 1.27 gram. Hence Q equal to IT. We are getting that we need to get the time. So Q divided by I, we are getting a value of, that is 3,860 divided by 2. Will get us the value of 1,930 seconds. 1,930 seconds. Why we are dividing by 2 is here I equal to 2 amperes. Here I equal to 2 amperes. I tell Q equal to IT. T, we are calculating T in seconds. Q given is the 3860 divided by I equal to 2 amperes. This is again and repeatedly appearing question both in Cbse and in state curriculum, more importantly in Cbse. Define molar conductivity of a solution and explain how molar conductivity changes with the change in concentration of a solution for both weak and strong electrolyte. I repeat the question. Define molar conductivity of a solution and explain how molar conductivity changes with the change in concentration of a solution for both weak and strong electrolytes. The definition of molar conductivity is molar conductivity of a solution is the conductance of a volume of a solution, capital V, containing 1 mole of electrolyte, that is the number of mole involved is 1, kept between 2 electrodes, anode and cathode, with the area of cross section, capital A, and a distance of unit length L. Again I repeat, molar conductivity of a solution is the conductance of a volume of a solution containing 1 mole of the electrolyte kept between the electrodes with the area of cross section, capital A, and a distance of unit length between the 2 electrodes is L. For strong electrolyte such as HCl, molar conductivity increases slowly with dilution. Molar conductivity increases slowly with dilution. For weak electrolytes, molar conductivity increases steeply. You may see in the graph, increases steeply on dilution. The weak electrolyte we are considering is acetic acid. Look into the graph carries half a mark. The limiting molar conductivity definition carries 1 mark, and the explanation for both the strong and weak electrolytes carry half mark each. That is, overall it comes to 2.5 or 3 marks in Cbse curriculum. Next, question number 6. The resistance of a conductivity cell containing 0.001 molar KCl solution at 298 Kelvin is 150 ohm. What is the cell constant if the conductivity? I repeat the question. The resistance of a conductivity cell containing 0.001 molar KCl at 298 Kelvin is 1500 ohm. What is the cell constant if the conductivity of 0.001 molar KCl solution at 298 Kelvin is 0.146 10 to the power minus 3 Siemens centimeter inverse? Given data, kappa, the symbol for conductivity, 0.146 10 to the power minus 3 Siemens centimeter inverse, resistance 1500 ohms, cell constant G equal to L by A. It is a formula. We can also alter L by A equal to conductivity into resistance, kappa into R. We have got the values. Conductivity 0.146 10 to the power minus 3 Siemens centimeter inverse, and resistance we have got 1500 ohms. Hence L by A equal to 0.219 centimeter inverse. That is the cell constant. L by A equal to G star. G refers to the cell constant. The last question of this post. Conductivity of 2.5 into 10 to the power minus 4 methanoic acid. Methanoic acid is formic acid. Is 5.25 10 to the power minus 5 Siemens centimeter inverse. Calculate its molar conductivity and degree of dissociation. Lambda m equal to kappa into 1000 by C. Lambda m we are calculating by the formula. We have got a conductivity kappa 5.25 10 to the power minus 5 Siemens centimeter inverse into 1000 divided by conductivity is 2.5 into 10 to the power minus 4. We are getting a value of lambda m molar conductivity of 210 Siemens centimeter square mole inverse. By incorporation of limiting molar conductivity, that is infinite dilution, lambda m of formic acid equal to lambda naught of H plus lambda naught of HCOO minus formate ion. We are getting it is equal to 400 Siemens centimeter square mole inverse. By degree of dissociation formula, alpha equal to lambda m divided by lambda naught m, that is 210. We have calculated molar conductivity divided by lambda naught m. By using limiting molar conductivity, we have calculated it to be 400. So 210 divided by 400 is 0.525. 0.525. Dear viewers, kindly subscribe our channel as we post more and more videos pertaining to Cbse and state board curriculum in the upcoming. The next will be part 2 of solutions, followed by chemical kinetics and coordination chemistry creatives. Thank you all.